Solving rational equations. When we're solving rational equations, our first step is to find the least common denominator. Next, we're going to multiply each term on both sides by the LCD, and then we want to cancel out the denominators. Then we'll be left with an equation formed by the numerators, and we need to solve it for the variable. Lastly, we need to check for any extraneous solutions. So remember, just because you solve for a value of x doesn't mean that it's always going to make the equation true. So we need to make sure that none of the denominators equal 0 when we substitute that value of x back in. So let's go ahead and follow the steps to solve this rational equation. So first we want to find the least common denominator, and before we do that, I'm just going to put this 9 over 1 so that now all of our terms look like fractions. So in finding the LCD, we need to see which terms each denominator is missing. So the first two have an x, this last one doesn't, so remember we need to multiply top and bottom by an x. The second one has a 3 and the other two fractions don't, so we're going to multiply the top and bottom of the first and the last one, so that now all the denominators are 3x, 3x, and 3x. Then we'll follow step number 3, cancel the denominators out. So now that they're all the same, we're just going to cancel all of them out. And then we want to solve the equation formed by the numerators. So we're going to take these numerators, multiply them out, and write the equation that's left. So 3 times 4 is 12. Then we have plus 1 equal to 9 times x times 3, which is 27x. And then we want to go ahead and solve this equation. So 12 plus 1 is 13, equal to 27x. Divide both sides by 27. And then we are left with 13 over 27 equals x. So we solve for x, but remember, this last step, we need to check for extraneous solutions, which means making sure that none of the denominators equal 0. So when you look at the original equation, before we multiplied through by the LCD, you want to look at those original denominators. So our denominators are x, 3x, and 1. When you substitute in that value of x, 13 over 27, and there's nothing to substitute here, none of these denominators are going to equal 0, which means that this is a solution of our equation. So we're going to work through a couple more examples and I'll show you a few different things, but we're going to follow those same steps. In this one, we need to find a least common denominator, but if you look, x minus 2 and x minus 2, they already have the same denominator. So we can go ahead and skip the first two steps and go straight to step number 3, which is cancel out the denominators. And then we're going to solve the equation that's left by the numerators. So the numerators leave us with this equation, and then we're going to go ahead and solve that. So we add 7 to both sides, and then we have 5x equal to 15. Divide both sides by 5, and then we're left with x is equal to 3. So there's our only value for x, and then remember, we have to substitute it back in. Our denominator was x minus 2, and we can just check it once since they were both the same. So we want to substitute in our value of x, and we get 3 minus 2 is 1, which is not equal to 0, which means that this is a solution of our equation. In this example, we need to find an LCD because our denominators are not the same. So let's start by putting parentheses around our expressions so that we can group them. And then we need to find that common denominator. This first one has an x minus 6, but the second one doesn't, so we want to multiply the bottom and the top by x minus 6. The second one has an x minus 4, but the first expression doesn't, so we want to multiply the top and bottom by an x minus 4. Then we can go ahead and take our next steps to cancel out the denominators and write the equation left over by the numerators. And now we want to solve this equation for x. So let's go ahead and distribute this x. So we have x squared minus 4x equal to x minus 6. And because we have a quadratic in x squared and x terms, we need to get everything on one side of the equal sign together. So we'll subtract the x from both sides. Then we'll add 6 to both sides. And we have x squared minus 5x plus 6 is equal to 0. So once you set your quadratic equal to 0, remember, in order to solve for x, we're going to need to factor this. So let's go ahead and factor. We have x, and then our factors of 6 are going to be 6 and 1, 2 and 3. We need them to add up to a -5, so we're going to take a -2 and a -3 and make sure that they also multiply to give us +6. So now that we factored, we set each factor equal to 0 and then solve for x. So we have x equals 2 and x equals 3. So our last step is to check for extraneous solutions. So remember, take your original denominators, x minus 6 and x minus 4, and let's go ahead and check those. So when x equals 2, and we substitute that back into both denominators, we'll get a value of -4 and -2. Neither one is 0, which means that x equals 2 is a valid solution. And if we substitute in 3 for x into both denominators, we have -3 and -1. And again, since neither one is 0, that is also a valid solution. There's one thing I just want to talk about from our initial equation. In x over x minus 6 equal to 1 over x minus 4, if you notice, we only have one fraction on the left side and one fraction on the right side. When this ends up happening for your rational equation, we can actually solve this like a proportion. If you put parentheses around your expressions and then you cross multiply, we end up with the equation that we actually have right here. So remember, this is a special case. You can only cross multiply when you have a rational equation with exactly one fraction on each side. And remember to put all expressions in parentheses before you cross multiply. You'll end up with the same solutions as you would if you follow our steps that we outlined in the beginning, but if you notice that you have one fraction equal to another, instead of going through the LCD process, you can just cross multiply. So let's just walk through another example together. So first we want to start off by putting our expressions into parentheses. And since we have a quadratic in the denominator, we actually want to factor that first to see what factors we're working with. So we have x, and then we'll have a +3 and a -2, so that they add up to +1 and multiply to -6. So we're going to use this as our denominator instead of that quadratic. So now let's find the least common denominator. We have an x minus 2 here and an x minus 2 here, but we're missing it in the middle term. So we'll multiply by x minus 2 on the bottom and on the top. And then we have an x plus 3 in the second and the third expressions, but not in the first one. So we multiply by x plus 3 on the bottom and the top of the first one. Now all our denominators read x plus 3, x minus 2. X plus 3, x minus 2, x plus 3, x minus 2. So now we can go ahead and cancel out our denominators and rewrite our numerators into an equation. When we distribute 1 to both of these, it's not going to change anything. So we have this equation, and then when we solve this equation, we get 2x plus 1 equal to 5, and then subtract 1 from both sides. We get 2x is equal to 4, divide both sides by 2, and then we have x is equal to 2. Now remember, our last step is to check for any extraneous solutions. So we take our original denominators, x minus 2, x plus 3, and then x squared plus x minus 6, and we want to substitute in our value of x. So 2 minus 2 is equal to 0. So since this denominator equals 0, we actually don't even have to check the other two denominators, because as soon as one of the denominators is equal to 0, we can go ahead and cross out that solution. So since x equals 2 was our only solution, but because it makes a denominator equal to 0, we actually have no solution for this rational equation. In this last example, I just want to point out what happens when you have a subtraction. We're going to change that to a plus sign and distribute a negative to the terms in the numerator of the expression that follow the subtraction. So the positive x becomes a negative x, and the minus 5 becomes a plus 5. Then we're going to go ahead and group all our expressions in parentheses. And then remember, any quadratics, we want to factor those. So let's go ahead and factor that. 2x minus 3 and 2x plus 3. And now let's go ahead and find the LCD. 2x minus 3 in the first and the last expression. So the second one needs a 2x minus 3 multiplied on the bottom and on the top. And then we have a 2x plus 3 in the second and the last one. So the first expression needs a 2x plus 3 multiplied on the top and the bottom. Now that all the denominators are the same, we can go ahead and cancel those out and then rewrite our equation that's left with our numerators. So we have 2x plus 3 times x plus 4 plus a negative x plus 5 times 2x minus 3, and that's equal to 21. So our next step in solving is to FOIL. So we have 2x squared plus 8x plus 3x plus 12. And then we have a negative 2x squared plus 3x plus 10x minus 15 equal to 21. And then when we combine like terms, a 2x squared minus 2x squared cancels out to make 0. So we have 8x plus 3x, which is 11x, plus 3x, which is 14x, plus 10x, which gives us 24x. Then positive 12 minus 15 gives us negative 3, and that's equal to 21. So then to finish solving, we add 3 to both sides, and we have 24x is equal to 24. Divide both sides by 24, and we get x is equal to 1. Now remember, even after all that work, don't forget to check for extraneous solutions. So we need to check our denominators. Now, since this one factors into the two denominators we have, we can just check 2x minus 3 and 2x plus 3. So when we substitute in our solution 1 in for x, we get 2 minus 3, which equals negative 1, and 2 plus 3, which equals 5. Since neither of these equals 0, that means none of the denominators will equal 0, so x equals 1 is the solution. That's it for this set of notes. I'll see you in class for more practice.